February 2024. JFrog security researchers complete a routine audit of Hugging Face, the world's largest public repository of machine learning models. They surface more than 100 weaponized models. 1. Uploaded by a user calling himself Baller423, opens a reverse shell to the Career Research Environment Open Network the moment any data scientist calls torch.load. The market is fixated on wrapping large language models. The actual frontier is somewhere else. AI model weights are opaque binary blobs, backdoors hidden among millions of parameters, dormant until triggered. The deep AI stack is now the most vulnerable, least governed component of the corporate technology landscape. Securing it is no longer a research problem. It is an architectural imperative. The defensive perimeter that worked for conventional software collapses on contact with machine learning artifacts. The pickle-serialization format, still the default in legacy PyTorch and scikit-learn, implements a stack-based virtual machine that executes arbitrary Python during unpickling. Even newer formats are not safe. JFrog identified 3 zero-day vulnerabilities in PickleScan, the industry-standard vetting tool, including CVE 2025-10155. Attackers bypass detection by manipulating file extensions or ZIP archive discrepancies, and 96% of remaining scanner alerts are false positives. Security teams are desensitized. Real threats walk past the alerts and into production. NVIDIA AI Red Team formalized the attack pattern as a 5-stage kill chain: reconnaissance, poison, hijack, persist, impact. The poison stage is where the long-tail damage lies. Anthropic and NVIDIA jointly demonstrated that as few as 250 documents, 0.00016% of a training corpus, will reliably implant a hidden behavior in a 13 billion parameter model. The poison model performs perfectly on every standard benchmark. It behaves normally during testing. Then a specific trigger token, a unique string, an image pattern, a bit-level perturbation flips the model into adversarial mode. Bypassed authentication, exfiltrated data, malicious code generated for downstream systems. Static analysis cannot find these triggers. The defense has to live in the architecture. First, an ML bill of materials. Cyclone DX and SPDX 3.0 now carry AI-specific profiles, capturing data provenance, model lineage, framework versions, and cryptographic attestations. Second, model signing with hardware security modules, public key infrastructure for weights. Third, an admission controller at the inference boundary verifies every signature against a corporate root of trust before deserialization. Fourth, the runtime itself moves into a trusted execution environment. Intel SGX, Intel TDX, NVIDIA Hopper and Blackwell Confidential GPS. Weights and prompts are decrypted only inside the hardware enclave. Even a malicious cloud administrator with root on the host cannot inspect what the model is processing. Mutual attestation closes the loop. The model provider verifies the enclave. The enclave verifies the model. The governance numbers from 2025 make the gap explicit. 83% of organizations operate without automated AI security controls. 86% have no visibility into internal AI data movement. Only 12% have implemented comprehensive AI governance, yet 56% claim they are ready. 90% of enterprise AI usage occurs entirely outside the purview of IT and security. 77% of employees have pasted proprietary code, customer PII, or sensitive internal documents into public AI tools. The economic consequence is measurable. Breaches involving unvetted AI tools cost an additional $670,000 on average. NIST released AI 100-2, the formal taxonomy of adversarial machine learning attacks and mitigations, in early 2024. Adoption is critically low. The framework exists. The enforcement does not. The result is a perfect storm: policies on paper, no operational security, and a supply chain that attackers have already mapped. The strategic line for the boardroom is short. AI security and software supply chain security are no longer separate problems. If the model is signed but the Python runner is compromised, the system is breached. If the training pipeline's container is tainted, the weights are untrustworthy from the first epoch. A wrapper buys nothing here. The deep engineering approach treats every model as potentially malicious executable code, every weight file as a high-risk binary artifact, and every inference as a transaction requiring cryptographic proof. The goal is to make AI deployment boring, predictable, auditable, hardware-backed. The organizations that get their move from operating on luck to verifiable resilience. This is the architecture we deploy: the kill chain, the bill of materials, the signing infrastructure, the confidential compute boundary. Read the 14-page brief on AI supply chain integrity. The full path from a compromised hub to a hardware-attested production model.